Hi everyone and welcome to the Leaving Cert Chemistry channel with myself, Emma Ronan, creator and owner of leavingcertchemistry.ie. Head on over to that website if you want any of the notes that I discuss in this video, or follow us on TikTok at leavingcertchemistry.ie and Instagram, and also over on Spotify, where we have completely free Leaving Cert Chemistry episodes on every single topic that you need to know for your Leaving Cert Chemistry exam, with helpful exam tips, tricks, exam structure and timing, and so much more. So you can visit us on any of those platforms, but for now it's all things the periodic table, which continues on from our previous two videos, and there is still more in the series to come for those question 5s in the Leaving Cert Chemistry paper. Okay, we're going to start off with our first scientist, Robert Boyle, who was the first person to define an element as a substance that cannot be split into simpler substances by chemical means. Now, we know we have a periodic table of elements, but how did that come to be as it currently is? So Humphrey Davy discovered some elements by passing electricity through compounds and splitting the compounds up into the atoms that make it up. Now, as more elements were being discovered, scientists tried to come up with some sort of a pattern or arrangement in order to arrange them by. So the first scientist that we're going to look at and his pattern is Dobereiner and his triads. So he looked at the atomic weights of elements and he noticed that the atomic weight of certain elements was approximately halfway between that of the one above it and the one below it. So for example, bromine was halfway between chlorine and iodine. So he grouped these elements into groups of 3 known as a triad. Okay, so unfortunately, few other cases of groups of 3 elements kind of followed this pattern. So it was classed more so as a coincidence. But his work is important as it was one of the earliest attempts to trace a relationship between properties of the elements and their atomic weights. And he arranged them looking at their atomic weights. So then we have John Newland and his octaves. So he arranged known elements at the time in order of their increasing atomic weights. The properties of the elements seemed to repeat every 8th element. He stated this fact in his law of octaves. However, now in our modern periodic table, we know that the properties do not repeat every 8th element. So Newland's octave, some of his failings, some elements had not yet been discovered. He should have left gaps in the periodic table instead of forcing them all to try and fit. So his law of octaves worked for only about the first 16 elements, and after that, elements were forced into groups where they didn't exactly have similar chemical properties. Next, we have Dmitri Mendeleev in his periodic table, and he arranged elements again in order of increasing atomic weight, relative atomic mass. He placed all elements with similar properties into the same vertical column group as part of a table. Because the properties of the elements repeated at regular intervals, the table was called the periodic table of elements. Now, Mendeleev left gaps in his periodic table for undiscovered elements. He did anticipate there would be more to be discovered, and he didn't make properties fit. He also reversed the order of some elements to make their properties fit a lot better. For example, iodine and tellurium, which in nowadays periodic table we do not need to reverse because they fall naturally when arranged in order of increasing atomic number. Henry Moseley then discovered this atomic number, in other words, the number of protons in the nucleus of an atom, and he showed that by arranging elements in order of increasing atomic number, they fell naturally into the correct groups based on similar chemical properties. Now we have the modern periodic table, and it's the arrangement of elements in order of increasing atomic number, in other words, number of protons. Transition elements are in a separate D block, in Mendeleev's they weren't. We have no gaps, Mendeleev left gaps, and we have the noble gases group 8 discovered. However, Mendeleev did not have the noble gases discovered at the time. Our properties of elements repeat every 9th element. Then we have the definition for atomic number. This tells us the number of protons in the nucleus of an atom, and it can also be represented by the capital letter Z. Mass number is the sum of the number of protons and neutrons in the nucleus of an atom, and this can be represented by the letter A. You do need to be able to calculate protons, neutrons and electrons, and the symbol is AMU, atomic mass units, as grams or kilograms are far too big of a unit to use. Next we have Francis William Ashton, which I will go into more detail in my mass spectrometer video, but he built the instrument known as the mass spectrometer to measure the masses of atoms. He found that a sample of neon gas consisted of 2 varieties of neon that had the same atomic number but differed in their number of neutrons. So he called these isotopes. Isotopes then, definition, are atoms of the same element, i.e. they have the same atomic number but different mass numbers due to having different numbers of neutrons. So for example, we can have carbon 12, 13 and 14, we can have hydrogen 1, 2 and 3, you can have chlorine, you can have neon. There are many different isotopes of elements. The last thing, or the second last thing in this chapter that I'm going to look at, is relative atomic mass, written as capital A small r, and it's the average of the mass numbers of the isotopes of a chemical element in a given sample as they occur naturally, taking their abundances into account and relative to 1/12 of the mass of a carbon-12 atom. So mass spectrometer is used to calculate and measure the different isotopes, the different masses of those isotopes, measure relative atomic mass, relative molecular mass, and it's used to separate and identify different isotopes, as I said, measure their abundances, and we need to be able to talk about the 5 processes of how the mass spectrometer works in order. So I will cover that in another video, as well as the electronic configurations that are left as part of our periodic table question 5. But a recap for now, you should be able to outline the contributions of Mendeleev, Bob Reiner, John Newland, Moseley to the structure of the periodic table, compare Mendeleev's periodic table with the modern periodic table, define an element as determined by Robert Boyle, define atomic number, mass number, and relative atomic mass, and define isotopes while giving examples. Head over to leavingsirchemistry.ie for more. Don't forget there's a chemistry podcast, and all notes are available over on that platform. Like and subscribe, and I'll talk to you in the next video.